Well, hello. Hello, everybody. We're doing more on solid three-dimensional shapes. And what is this, Charlie?
A prism.
A triangular prism. As you can see, it has 1, 2, 3, 4, 5, 6 vertices.
And there are different kinds of prisms. And if you hold prisms up to the light, they make a rainbow.
They make a rainbow. This one has 6 vertices. It's got 1, 2, 3, 4, 5 faces. 6 and 5 is 11. And the edges is 1, 2, 3, 4, 5, 6.
7, 8, 9.
7, 8, 9. So 11 minus 9 is the magic number 2. So far,
It's always 2.
Euler is correct. Now this here is a pentagonal prism. It's a pentagon and another pentagon joined together. And you can see it has 5 vertices on each side. So 5 and 5 is 10 vertices. If you look at the faces, there's 1, 2, and then 5 along the side. That's 7.
Hey, I think you mean, so there's 10.
10 vertices.
There's 10 vertices. There's 7 faces.
And that's 17.
And
Let's look at the edges.
15.
5 here, 5 here, and 5 more, 15. 17 minus 15 is the magic number 2. Now this here is a hexagonal prism. I made it out of paper. There's a hexagon here, and they're joined together with paper. Okay, so it's got 6, 12 vertices. 6 on this side, 6 on this side make 12.
Wait, I was doing the, what was that last one called?
Pentagonal.
Well, we were doing the pentagonal.
Oh, yeah.
And then we were also doing the house.
Charlie discovered that the house has the same exact number of vertices, faces, and edges as the pentagonal. And it makes sense.
It's
Because
the same thing on the piece of paper, but if it has a shape, then it wouldn't.
Yeah, this here has 5 sides. This has 5 sides, and they're joined together. So it's just an irregular, as opposed to a regular pentagonal prism, the shape of a house. So that was good thinking, Charlie. I'm glad you noticed that. I didn't notice it. All right, now the hexagonal prism has 6, 12 vertices, 6 on each side. It's got 6 and 2 make 8 faces. 8 and 12 make 20. Now, let's count the edges. 6, 12, and then another 6, 18. 18 edges. 18 subtracted from 20 is the magic number 2. We're going to try and find some more three-dimensional shapes.
You want to see 8 faces, 6 edges, 12 V plus F minus E equals 2.
Tetrahedron.
Tetrahedron. And 4 vertices, 4 faces, 6 edges, V plus F minus E equals 2.
Octahedron.
And 5.
What's next?
Pyramid.
Pyramid. I don't have a pyramid here. It's in the garage.
5.
Oh, here's a pyramid.
Faces.
Yeah.
5.
5 faces.
8. V plus F minus E equals 2.
All right. What's next?
Octahedron.
Here's an octahedron.
Vertices, 6 faces, 8 edges, 12. V plus F minus E equals 2.
Okay. Dodecahedron? I don't have one of those.
Dodecahedron. 20. 20 faces, 8, edges, 12. V plus F minus E equals 2.
What's next?
Icosahedron. Vortices, 12 faces, 20 edges, 30. V plus 7 minus E 2.
Buckyball.
Trigonal
by pyramid. I don't have a trigonal by pyramid. But it would be like putting two of these together.
By pyramid.
Wait, I should have it. Here it is. I got it.
5.
1, 2, 3, 4, 5.
Faces, 6.
3, 6.
9.
3.
3 plus F minus E equals 2.
Buckyball?
Buckyball.
That's a big one.
60. Faces, 42. Edges, 90. V plus F minus E equals 2. How would this be? 60.
Which one are you doing? Which one are you doing?
House.
Oh, house. How many?
10 faces, 7 edges, 50. V plus F minus E equals 2.
There's no exceptions. Well, we did the others.
Triangle Prism. Vortices, faces, 5, edges, 9. E plus F, V plus F minus E equals 2.
Pentagonal.
Pentagonal pyramid.
Prism. Prism.
Pentagonal prism. Vortices, 10. Faces, 7. Edges, 15. V plus F minus E 2. Hexagonal
Prism.
12 vortices, 8 faces, 18 edges. V plus F minus E equals 2.
So far, we haven't found any exceptions. Thank you for your attention, and we're going to be looking for some new solids.
We could do some more where is it 2?
Well, they're not flat faces, though, right?
I know.
Yeah.
We can do one without faces.
Well, a football would have one face, 2 vertices, and really no edges. So V is 2, F is 1, and E is 0, so V plus F minus E is 3 rather than 2. But that's not a regular solid.
Looks like the one without flats.
That's a shape.
Always equals 301.
Well, yeah, they're probably all different values. That's true. All right, thank you for your attention, and we'll see you next time.